Have you ever wondered how a star dies? Or better yet, what happens while it's dying? Almost always the answer is supernova. But before looking at the graveyard of a star, let's talk about its life first. There are millions of the stars in our galaxy, but now the question arises, how does the stars formed? Or where does it come from? Basically, these stars are formed in the clouds of dust and gas. The massive clouds in the universe experiences their own gravitational forces and begin to collapse, so it fall on itself, dense at the center. Now, as we move to the center of the cloud, it becomes denser and denser and hot too, due to the gravitational forces. Now, because of the gravitational force, the dust and gas particles are brought so close at the center so that these particles begin to stick to each other. Then result to form a star of hydrogen atom. These hydrogen atoms fuse to form helium, and it creates the energy that powers every star. The life of the star depends on the size of the star at its birth. When the star is small, there is a balance between the gravitational force and the pressure due to fusion of particles. When time goes on and the star becomes supergiant, and then the distance between the center and the edge of the star goes on increasing, that results to weaker the gravitational force between them. As the gravitational forces between the center and the edge become weak, the star is unable to hold itself, and the explosion of the star takes place, that is termed as supernova. This explosion possesses very high energy, such that it can light up our whole galaxy, and we can also see it through Earth's surface, through naked eyes. So, what's supernova? A supernova is an explosion of a massive supergiant star. It may shine with the brightness of 10 billion suns. Yes, it's too huge and too massive. As I mentioned, supernovas happen to huge stars, supermassive stars, so our sun is not gonna experience it. The total energy output may be 10 to the power of 34 joules, as much as the total output of the sun during its 10 billion year lifetime. The likely scenario is that fusion proceeds to build up a core of iron. We can say it's the end of the star life. On average, a supernova will occur about once every 50 years in a galaxy the size of the Milky Way. Well, after supernova, it leads to the formation of a black hole. If a star has 3 times or more the core mass of the sun and collapses, it can form a black hole. Don't let the name fool you. A black hole is anything but empty space. Rather, it is a great amount of matter packed into a very small area. Think of a star 10 times more massive than the sun, squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing, not even light, can escape. But a supernova is not only leading to form black holes. A supernova is home to form new stars and other celestial bodies. The temperature in a supernova can reach 1 billion degrees Celsius. This high temperature can lead to the production of new elements which may appear in the new nebula that results after the supernova explosion. One very famous nebula that formed after the supernova is the Helix Nebula. which probably most of you have already seen its stunning pictures. Scientists have learned a lot about the universe by studying just supernovas. They use supernova like a ruler to measure distance in space. They have also learned that stars are the universe's factories. Stars generate the chemical elements needed to make everything in our universe. At their core, stars convert simple elements like hydrogen into heavier elements. These heavier elements, such as carbon and nitrogen, are the elements needed for life. So let's for a moment appreciate the effort a star makes to recreate life by dying so beautiful and so powerful that almost nothing in the universe could be compared to it.